what is differentiation? Differentiation, this is the process of finding the gradient function. So whenever we are differentiating a function, we'll be finding the function which defines its gradient. So we are going to start by differentiating any polynomial of the form ax to the power n. If we have any function, for example, f of x is equal to ax to the power n, the general rule that we use for differentiating gives us that dy over dx, which is the gradient function, should be equal to a multiplied by n multiplied by x to the power n minus 1. So this is the general rule for differentiating any function of this form. So, for example, we can say find the derivative of y equals to x squared. We are differentiating with respect to x. We are differentiating with respect to x. So what do? We just write dy over dx is equal to 2 times 1, which is 2x to the power 2 minus 1, which will give us 2x. So this is the gradient function. So for a function which was y equals to x squared, the gradient function is equals to 2x. Another example is for the function f of x is equal to 4x cubed. We need to find this the gradient function for this function. We are differentiating with respect to x. We are differentiating with respect to x. So dy over dx, which can also be written in the form f dash of x, which means the first derivative of x is equal to 4 by 3 by x to the power 3 minus 1, which will give us the first derivative of x is equal to 12x squared. So this is the differential of 4x squared. So we move on to another concept. We want now to differentiate polynomials. Differentiation of polynomials. We want to differentiate polynomials. So basically, a polynomial is any mathematical statement which has got many parts, because a nomial means part and poly means many. So we want to differentiate any mathematical function which has got a lot of parts. For example, given that f of x is equal to x cubed plus x squared plus x plus c, or let's just say plus 4 to make it simple. So we are saying we want to differentiate this polynomial because it is containing many parts. So whenever we're differentiating polynomials, we differentiate part by part. So we say dy over dx is equal to 3x squared plus 2x plus 1 plus 0. Why did I say the differential of 4 is 0? Is because the differential of a constant is always a 0. So whenever we differentiate a constant, our result is a 0. So the differential of this function is equal to 3x squared plus 2x plus 1. So we can exclude a 0. So it will remain 3x squared plus 2x plus 1. Going on to another example, we can differentiate a function of this nature where we are saying f of x is equal to negative 3x to the power minus 2 plus x to the power minus 1 plus 6. We want to differentiate this function. So we just say dy over dx is equal to minus 3 multiplied by minus 2 multiplied by x to the power minus 2 minus 1 plus minus 1 multiplied by x to the power minus 1 minus 1 plus 0. So what is the result? We are saying this is 6x to the power minus 3 plus negative x to the power minus 2. So this will give us 6 over x to the power 3 minus 1 over x to the power 2. So this is our result. We have found the gradient function for this polynomial. Dy over dx is equal to this one. Moving on to another concept, we can find the differential of composite functions. We want now to look at the composite functions. composite function. Composite functions, these are functions of another function. For example, we can say y is equal to 4x plus 3 all raised to the power of 2. So we are seeing that in the brackets there is a function, and as a whole it is another function. So it is a composition of functions, which means it is a function of a function. So whenever we are going to differentiate these composite functions, today we are going to use substitution method. So when we want to find the gradient function, firstly we say let u be equal to 4x plus 3. Then this we can term it equation 1. So we differentiate equation 1 with respect to x. It will give us du over dx is equal to 4. And if u is equal to this implies that y is now equal to u to the power 2. So what is the differential of y equal to u to the power 2? dy over du is equal to 2u. Therefore, we now want to find dy over dx. Now want to look for dy over dx. So dy over dx is now equal to du over dx times dy over du. So this is equal to what? To 2u times 4, which gives us 8u. But u is equal to 4x plus 3. So this implies that dy over dx is equal to 4 is equal to 8 by 4x plus 3 to the power 1. So we can leave it just like that. So this is the differential for this composite function. Then the last example, we can have another function, composite function, which would be like function of x is equal to the square root of 4x to the power minus 3 plus 2. Like this. We want to find the derivative of this function. So we are saying let u be equal to 4x to the power minus 3 plus 2. Differentiating this function with respect to x, it will give us what? Du over dx is equal to minus 12x to the power minus 4 plus 0, or it will just remain minus 12x to the power minus 4. So if u is equal to this, so we can substitute 4x to the power minus 3 plus 2 by u, and the function will give us f of x is now equal to the square root of u. So the radical sign only implies that the function is being raised to the power half. So f of x is equal to u to the power half. Differentiating this with respect to u, it will give us dy du. It will give us dy over du is equal to half u to the power half minus 1, which is half u to the power minus half. So what is dy dx? Dy over dx is now equal to dy over du times du over dx, which is equal to half u to the power minus half times minus 12x to the power minus 4. So this gives us minus 6 u to the power minus half x to the power minus 4. So but u is equal to 4x to the power minus 3 plus 2. So this implies that dy over dx is now equal to minus 6 open bracket 4x to the power minus 3 plus 2 all raised to the power minus half. So this is the final answer. This is the gradient function for this function. We've differentiating this composite function with respect to x. So for today, this is what we're doing, the differentiation process, where we said it was the process by which we'll be finding the gradient function. So today we did differentiation of a function of the form ax to the power n, and we did polynomials. We also did composite functions. So in our next lesson, we'll meet and discuss the differential of a function being multiplied by a function, or we can just say product of a function. Then we look for a differentiation of quotients, where we'll be differentiating what? Fractions. So this is what we'll do in our next lesson. So meet you on our next lesson.